Running indoors on a treadmill is slightly easier than running outside because you aren't moving through the air and there is no drag force to oppose your motion. A 65-kilo man is running at 4.5 meters per second on an indoor treadmill. To experience the same intensity workout as he'd get outdoors, he tilts the treadmill to a slight angle, choosing the angle so that the component of weight force down the ramp is the same as the missing drag force. What is the necessary angle? So let's try and understand this problem conceptually first. So we have a man who is running hypothetically outdoors at some velocity that we don't know, and he experiences a drag force in this direction, right? And this, we'll call this D as the drag force, and this is him running in this direction. The drag force is in this direction. Now let's picture the same man running on a treadmill. And now there's no drag force on him because he is stationary and he's running indoors. So because of the fact that he is physically stationary, there's no drag force. But however, he has tilted the treadmill at an incline, so the component of weight force down, so this is his weight directly down, which is weight is equal to mg, and the component of his weight force down, which is perpendicular to the force normal, will be mg sine theta. So the gist of this problem is in this: him choosing an angle so that the component of his weight force down equals the same as the missing drag force. So this is the key to the question. So we set the drag force equal to the component of his weight force down, which is mg sine theta, as he's on the treadmill. So he can experience the same intensity workout as if he were running outdoors, because the angle would account for this extra force that he'd have to put into to compensate for that extra intensity workout if he'd be running outdoors. So our formula for drag is 1/4 times the density of air times the cross-sectional area of the person as he's moving through the air times his velocity squared. And we can set that equal to his mass times acceleration due to gravity times the sine of the angle. Sine theta is always, remember, sine theta is always a vector downward, and cosine theta is the vector that is adjacent to the surface. So we know our density of air given to us as 1.20. I won't write the units, but it's kilos per meter cubed. The cross-sectional area is 0.72 meters squared, and the velocity is 4.5 meters per second. We set that equal to our mass of the person, which is 65 kilos, times the acceleration due to gravity, 9.8 meters per second square, times sine theta. So let's solve for the left-hand side. Once we solve for the left-hand side, we end up with 4.374. We can just call this newtons. It winds up into kilos kilos times meter per second squared, which is the same as saying newtons, equals to 65 kilos times 9.8. So we have 637 newtons on this side too, times sine theta. Our newtons cancel, so we have our sine theta equal to 4.374 divided by 637, and our theta equal to the sine inverse of whatever this value is, 4.374 divided by 637, sine inverse of 0.006866, and that gives us an angle of 0.39 degrees. So that's our answer. Our answer is 0.39 degrees. It is the angle with which he will tilt up the treadmill to experience an added force that will be equal to the drag force had he been running outdoors to experience the same intensity workout.